Okay, chapter 25.2, Inner Planets. This is the second of 4 sections. We will be done by the end of Thursday. Friday, don't forget, is your review. Your test will be on Monday. So it's whatever day your period has its final. It should not take you all 2 hours of the final to get the test done. By the time we're done, you should be able to describe features of the inner planets and compare each of the inner planets to Earth and to one another. So how do we know all this information about any of the planets anyway? Because obviously we have been to the moon and that's as far as we've ever been. However, we have sent up satellites that have flown past and taken images, and we have sent rovers actually to some of the planets, not all of them, but some of them, who have collected samples. Those samples then come back to Earth, and we analyze them here on Earth to get a lot of information. Are we good? There are 4 inner planets that are considered inner planets. They are the 4 planets closest to the sun. We also call them the terrestrial planets because they are all made of rock and metals, as we talked about yesterday. Those are Mercury on the inside most, Venus, Earth, and Mars. Are we good? Good. I'm seeing heads move today. That makes me smile. Mercury and Venus have no moons. Earth has 1 moon, and Mars actually has 2. Our orbits, obviously, since we are closer to the sun, our orbits are going to be shorter orbits than the outer planets. And we actually spin on our axis more slowly than the outer planets do. Even though our orbit is shorter, so is our spin. We spin a lot slower than the outer planets. We, as I said, we are almost all cooled rock. We're rock. We rock. Sorry. It is mostly igneous rock, which means that it formed. Okay, who's going to remember? What did igneous rock form from? Yes, somebody remembered. Thank you. Good. I'm so proud of you. Igneous rock formed from lava. Okay, so almost all of these planets are formed from igneous rock. That means they formed from some kind of lava, but they all have iron cores. Obviously, if there is lava on there, at some point there were volcanoes, but there were also earthquakes and that kind of activity also. And none of us have rings. None of the inner planets have rings. It's very sad. I kind of wish we did. I think it would be cool. So we're going to talk about each planet individually. Earth, I'm not going to spend a lot of time on any of them because I want to get through this. But I'm not spending a lot of time on Earth because that's what we've been talking about all year. You should know that we have large oceans. We have liquid water. We have big, huge areas of land, and we have a very active atmosphere. We've talked about our atmosphere and our oceans and our land. Our average surface temperature is 57 degrees. That kind of surprised me when I learned it. I always thought our average temperature would be higher than that, but when you take into account, we're talking about not just the equator and where we live, but we're talking about the equator all the way up to the poles, and we know how cold it gets at the poles. We know how hot it gets at the equator, so that averages out to about 57 degrees. We are the only planet that has water in all three forms, solid, liquid, and gas. As of now, we are also the only planet that has life as we know it. We think that that is because we have liquid water and because we have this wonderful atmosphere that has filtered out some of the harmful radiation coming from the sun, and it actually allowed life to develop. Thank you. During formation of the Earth, gravity pulled the heavier materials to the center. Heavier materials are always going to go to the center if there's gravity involved, which created our iron core, iron and nickel core. The heavier rock then started melting and made up the mantle, and the lighter rock kind of floated to the top and became our crust. Kind of makes sense. We good? Okay. Yes?
Yes.
Okay. Earth has tectonic plates. Those plates move on the mantle. Hello, we've already talked about that. We've already talked about the fact that this movement is what creates our earthquakes, our volcanoes, and our mountains. I may not be able to say the words, but they are right there. Earthquakes, volcanoes, and mountains. As far as we know, everything that we have seen has said that we are the only planet to actually have plate tectonics. We are not the only planet to have volcanoes and stuff. Remember, we've talked about that. But we are the only planet that those volcanoes are caused by the movement of the plates over our mantle. We know that Earth rotates on its axis one time every day. That's what makes a day. It starts here. The axis is here. If we start here, it takes one day for us to turn around like this and come back to our original spot. It takes us 1 year to go all the way around the sun. That's 364.25 days. We do 365, right? We have a large moon. We are the only one that has a large moon compared to us. Okay, it is not a large moon compared to other moons, but when you compare it to our size, it is large. And it orbits Earth once every 29.5 days or once a month. Mercury, going to start at the very closest to the sun, smallest planet. We don't know as much about Mercury as we do about some of the other planets because it's hard to get a satellite that close to the sun. However, we did send MESSENGER. MESSENGER stands for Mercury Service Space Environment Geochemistry and Ranging Satellite. Right? it was able to get there and go around Mercury and get some information, and it actually mapped the surface of Mercury. You see, Mercury is not a planet that looks anything like ours. It has lots more impact craters, but these craters seem to be billions of years old. It doesn't seem to be being hit recently. Doesn't have hardly any atmosphere, so there is very little weathering or erosion. And while our year is 365 days, Mercury's year is only 88 of our days. So its orbit around the sun is a lot faster than ours. However, Mercury rotates really slowly, so its day is only 57 is actually sorry, not only. Its day is 57 Earth days long. So a year on a day, I get this backwards, sorry. A year on Mercury is only 1.5 Mercury days. Can you imagine if that was ours? Do you know how old you'd be? You'd be so old by now. If you had a birthday every 1.5 days, holy cow, that's crazy. Okay. Because there is no atmosphere and because it is so close to the sun, the temperatures can reach 801 degrees Fahrenheit. Okay, again, I am a fair weather girl. I like warm weather. That's a little too warm for me. Thank you very much. In the dark places, though, it can drop to negative 297 degrees. Oh, yay, that's so much better. It has a very dry surface, except there may actually be water ice at the poles. Because the poles, it's not going to have the sunlight, like the direct sunlight that this part is going to have. It's kind of like our poles. We believe that it actually has a large liquid iron core. It's small enough that the pressure isn't great enough to make that a solid iron core. Venus. Thick clouds, lots and lots and lots of thick clouds. Because of those thick clouds, it reflects light, making it really bright in our sky. It is the most similar in size and density to Earth. It's also the closest planet to us. So a lot of people go, well, if it's the closest planet to us, then why aren't we looking at it instead of Mars, right? Well, because the conditions on it are not as good as the conditions on Mars for us. It has a large iron core and a silicate mantle, just very similar to what ours is. It's weird because it rotates backwards. So instead of the sun rising in the east and setting in the west, it would appear that the sun would rise in the west and set in the east. So it rotates backwards compared to the other planets and compared to its direction that it orbits the sun, which is unusual for a planet. Most planets orbit in the same way that they rotate. One Venus day is 243 Earth days. So talk about rotating slowly, right? Not as slow as we do, but a lot slower than Venus does. Good. Now, okay, wait. I'm going to go back for a minute because I want you to notice something. I want you to notice something. Look, a Venus day is 243 Earth days, right? A Venus year is 224 Earth days. That means that the year is shorter than the day. How weird would that be? Thank you very much. Its year is shorter than its day by about 10 days, right? How weird. And as to why we can't live there, the clouds here, unlike our beautiful, wonderful clouds, which are water, right? The clouds on Venus are carbon dioxide, sulfur dioxide, and worst of all, sulfuric acid. So when it rains there, it's not rain coming down, it's sulfuric acid coming down out of the sky. Not a good thing if you're trying to live there. Carbon dioxide from the planet creates lots and lots of greenhouse gases, which creates the greenhouse effect, which traps the heat. And temperatures on Venus, even though it is farther away than Mercury, temperatures on Venus can get up to 860 degrees Fahrenheit, which is hot enough to melt lead. Again, not any place we could live because of that. Atmospheric pressure is also 90 times what Earth's atmosphere is. So think about how much you weigh right now and multiply that times 90, and that's what you would weigh if you lived on Venus. So if you weighed 100 pounds, you would weigh 9,000 pounds. Humans would not be able to move with that kind of atmospheric pressure, so we can't be moving there. This is also a picture of Venus. This is actually a radar picture of Venus because the clouds are so thick that we can't see through them to see the surface. So we sent satellites that have radar on them to map the surface of Venus. And what we found is Venus isn't just this lump of rock. It actually has mountains and valleys and canyons and volcanoes. All the same kind of stuff that we have is on the surface of Venus. Good? Okay. We also discovered that Venus's surface is pretty young, which tells us that there is lots of volcanic activity going on there. And it's not just volcanic activity in one place. This is like, it covers the entire planet. Volcanoes erupt all over the planet and create new surface. What we believe happens is much like what happens with us, only we have smaller volcanoes. The heat builds up and builds up in the mantle until it actually destroys most of the crust. And then the volcanoes just explode everywhere and you get almost a brand new surface. Again, not someplace we want to live. Then we jump to Mars because we've already talked about Earth. Mars is the fourth planet from the sun. Mars is the first planet and the only one of the inner planets that is outside of Earth's orbit. The rest of them are inside. It is smaller. It's colder. I don't know why that says colders, but it does. And it's drier than Earth is. Notice I have a question mark after no life, because we don't know for sure whether there was ever life on Mars. There may have been life on Mars at some point. We just don't know for sure. But we do know that it has lots of volcanoes. Mars is obviously more studied than any of the other planets. We've kind of already talked about that a little bit. NASA, National Aeronautics Space Administration, that's our space people, and the European Space Agency, both hope to send people to Mars between 2030 and 2040, so in the 2030s. As you probably remember, if you watch the video, it's red because not, just because it's filtering out blue light, but because there's actually a lot of iron oxide on there. Mars is a rusty planet. It has much thinner atmosphere, which means that the atmospheric pressure is also lower than what we have on Earth. That atmosphere is mostly carbon dioxide, which you would think would make it have a really big greenhouse effect, because carbon dioxide is one of the biggest greenhouse gases there is. But it doesn't, which we think is a little odd. It has mountains, canyons, volcanoes. You notice that that is kind of on every inner planet. We have mountains, canyons, and volcanoes. However, Mars has the largest volcano and the largest canyon in our solar system. Olympus Mons is a shield volcano. Remember, shield volcanoes form when the lava comes out nice and smoothly. It doesn't erupt violently. It just kind of bloop, bloop, bloops. Okay. And it is the biggest. You can tell it's pretty darn good size. This is from space, and you can see it very, very well. Largest in our solar system. And Valles Marineris is the largest canyon. No, this is not really the United States is not on Mars. This is if you took a picture of the United States. This is as big as the United States is. You notice that that canyon would go all the way across the United States and still have room on both ends if you look. Okay? So Valles Marineris is the biggest canyon in our solar system. It makes our wonderful Grand Canyon look like a baby. Yes? Mars does have water ice at the poles, and we think just under the surface. We believe there may have been some liquid water there because some of the canyons that we find there look like they are eroded with water, much the same way our Grand Canyon is. And as you can see in this picture, Mars has two moons, Phobos and Deimos. I think that's the last one for today, isn't it? Okay.